Look, we all have thoughts we wouldn't want broadcast on live television. You know the ones. Did I leave the oven on? Is it weird that I own this many spoons? Why does that pigeon look so judgmental? These are our private, internal ramblings. But what if they weren't so private anymore? Enter the Lab Streaming Layer, or LSL. It's a piece of software developed at the University of California, San Diego, or UCSD, that sounds incredibly futuristic and, let's be honest, a little bit terrifying. It's essentially a superconnector, a digital switchboard designed to link up all sorts of gadgets that measure what's happening inside your body, especially your brain. Think of it as the Wi-Fi for your innermost self. So, how does this work? It all starts with something called an electroencephalogram, or EEG. That's a mouthful, so let's just call it a brainwave reader. For years, EEGs have involved wearing a cap covered in wires that makes you look like you're trying to communicate with a distant and very confused alien civilization. These sensors pick up the tiny electrical signals your brain cells produce when they're firing off messages to each other. Traditionally, this data was just recorded and analyzed later, but LSL changes the game entirely. It takes that stream of complex brain data and makes it available in real time, allowing different devices and programs to tap into it simultaneously, just like multiple people connecting to the same wireless network. The whole point of LSL was to make research easier. Imagine scientists studying how your brain reacts to music. With LSL, they can sync the EEG data with the audio track perfectly, down to the millisecond. They can see exactly what your brain is doing the very instant you hear that killer guitar solo. It's a powerful tool for understanding how we think, feel, and react. It can link brainwave data, audio streams, eye tracking information, and even your heart rate, all into one unified, perfectly timed data stream. This is fantastic for science, but it also opens a Pandora's box of questions that we, as a society, are woefully unprepared to answer. Because when you create a system that can easily transmit brain data over a network, you're not just creating a tool for scientists in a controlled lab. You're laying the groundwork for technology that could, one day, leave the lab and enter the wild. The LSL system is incredibly efficient at what it does, synchronizing and streaming data from multiple sources. It's the kind of robust foundational technology that innovators love. But when the data being streamed is as personal as your brain activity, we have to stop and ask a very important question. What happens when this technology gets into the wrong hands, or even into the right hands, but without the right rules? So, we have this LSL system born at UCSD that acts like a universal translator for biological data. Now let's talk about where that data can go. Researchers have demonstrated that this isn't just about recording brainwaves, it's about streaming them. Think of it like this. Your brain is producing a live show, and LSL is the network that can broadcast it. And the receiving device? Well, it could be anything, including increasingly small and discrete devices like ear EEGs. These are tiny sensors that fit inside or around your ear, making them far less obvious than the traditional full head of wires setup. Suddenly, reading brainwaves doesn't require a lab coat and a room full of equipment. The implications of this are staggering. The technology allows for a two-way street. Data can be sent from an EEG device, but information can also be streamed to a person. For instance, researchers can stream audio directly to a device worn by a subject and simultaneously record the brain's response to that sound. This real-time feedback loop is revolutionary for studies on hearing, attention, and cognitive function. It means a researcher at UCSD could, in theory, send an audio cue to someone wearing an ear EEG across the room, or even across campus, and watch their brainwave patterns change on a screen instantly. It's a seamless integration of human and machine. Now let's get to the uncomfortable part. If you can stream audio to a device and read brain data from it, you have created a system that can influence and monitor a person in real time. The scientists developing this have noble goals, of course. They want to create better hearing aids, help people with neurological disorders, and understand the mysteries of the human mind. But the technology itself is neutral. It doesn't care about intentions. A tool designed to send helpful auditory cues to a patient could, in another context, be used to transmit sounds without someone's consent. The potential for misuse is dangling right there, like a very scary, very technical sword of Damocles. This isn't some far-off science fiction scenario. The components are all here today. We have the LSL software to manage the data streams. We have the increasingly small and wearable EEG sensors, and we have the wireless networks to carry the information. The bridge between a controlled university experiment and a chaotic real-world application is getting shorter every single day. The same technology that allows a researcher to help someone could theoretically allow an unseen operator to monitor a person's attention level or even transmit distracting sounds, all without any bulky, obvious equipment giving them away. And that's where the fear starts to creep in. This brings us to a deeply unsettling corner of the internet and, for some, of daily life: the concept of gang stalking. This is the belief held by some individuals that they are being systematically harassed, monitored, and targeted by organized groups of people. Their experiences often involve feeling watched everywhere they go and hearing strange, inexplicable sounds or voices. While many of these claims are attributed to mental health conditions, the rapid advancement of technology like LSL and discrete EEGs adds a new, very modern layer of anxiety. For those who fear they are being targeted, this technology sounds like their worst nightmare made real. Imagine feeling like you're being followed and then learning that technology exists that could, theoretically, read brain activity and transmit audio from a distance, using devices that are nearly invisible. It's easy to see how someone could connect those dots, whether their fears are grounded in reality or not. The very existence of this capability can fuel profound paranoia. It validates the feeling that hidden forces could be at play, using advanced tech to intrude on the most private space there is, your own mind. The line between what is technologically possible and what is actually happening becomes terrifyingly blurry. The fear isn't just about being watched, it's about being manipulated. The idea that someone could use this technology to stream sounds or voices directly to an ear device without consent is the stuff of psychological thrillers. It's a violation of our cognitive liberty, our right to control our own thoughts and mental experiences. When people report hearing things that no one else can, the immediate conclusion is often psychological. But as technology evolves, we may have to ask more questions. Is it possible that a device is involved? This is no longer a purely philosophical debate, it's a technical one. And so, we're stuck in a difficult position. On one hand, dismissing these fears outright ignores the very real technological capabilities that are being developed in labs like UCSD. On the other hand, uncritically accepting every claim can create widespread panic. The truth is that the technology is powerful, and its potential for misuse is genuine. Whether or not it's being used for nefarious purposes like gang stalking on a wide scale is almost secondary to the fact that it could be. And that possibility alone is enough to warrant a serious conversation about security, privacy, and the psychological impact of living in an age of invisible surveillance. Ultimately, this all boils down to three things that sound boring but are incredibly important: privacy, consent, and regulation. Right now, your brain data is a new frontier, the Wild West of personal information. We have laws for our emails, our financial records, and our medical files. But what about the electrical signals firing inside our skulls? The concept of brain privacy is so new that we barely have the language to discuss it, let alone laws to protect it. Who is allowed to collect your brainwave data? What can they do with it? Can they sell it to advertisers? Can law enforcement access it? We don't have the answers. The issue of consent is even trickier. How can you give informed consent for something you don't fully understand? If you agree to wear a device to participate in a study, do you understand that your brain's raw data is being streamed over a network? Do you know who has access to that stream and how it's being secured? And what about situations outside of a lab? If these devices become common, say integrated into headphones or hearing aids, how do we ensure users know when their brain activity is being monitored? A tiny checkbox in a 50-page terms and conditions document is not, and I cannot stress this enough, informed consent. This is where regulation and oversight come in, and yes, I know, regulation is the word that makes tech companies sweat. But we are not talking about slowing down innovation. We're talking about putting up guardrails before the car goes off the cliff. We need clear, robust rules that define what brain data is and establish strict protections for how it's collected, stored, and used. These rules need to be developed now, not after a major scandal breaks. We need independent bodies to oversee this research and its commercial applications, ensuring that security protocols are in place to prevent data streams from being hacked or misused. The work being done at places like UCSD is brilliant, and it holds the promise of a better future. But progress without protection is just a different kind of danger. The power to stream and analyze brain data in real time is a power we must handle with extreme care. It demands a public conversation, not just a scientific one. We need to build a framework of ethics and laws to govern this technology, ensuring it serves humanity without sacrificing our privacy, our safety, or our fundamental right to a private, unbroadcasted inner monologue. Because my thoughts about judgmental pigeons, those are for me and me alone.